And what unit goes on a velocity? Meters per second. Questions? Okay. Questions about how to do that tomorrow on the test? Because remember, when I'm grading your test, I should see math problems worked out on the test. I shouldn't just see a bunch of circles. All right, number 2. These two are shorter. How do you find the force if we drop something from a building? Y'all did this yesterday. Everybody should tell me how to do this.
Oh, not funny.
Okay, so we're using F equals mass times acceleration, right? So force equals what's the mass of this ball? And what's the acceleration if it's dropped? Very good. Now, a couple of us forgot our units yesterday. What unit do you put on this answer of 24.5? What are y'all finding? A Newton. Because you're finding a force, it's a Newton. Not very many people wrote meter per second, but a bunch of people wrote what? A bunch of people wrote kg. All right, it's Newton.
Why?
Because it's a force. Anytime you find a force, it's a Newton. Okay, it's never a kg unless you're finding a mass. All right, the last one. What did I give you in the question?
What is the mass of a man?
What is the mass? And I gave you a what?
Oh, wait.
Weight. So what formula did we learn yesterday that had weight in it? F equals mg. Now, if you forget that tomorrow, look at your yellow card. Because some of you are going to forget the formula for weight. It's on the yellow card tomorrow. F equals mg. All right, so F is what?
200.
That's 200. That's his weight. Okay, M stands for what? Mass. And what's G? 9.8. So how do we solve for the mass? Divide by what? 9.8. So 200 divided by 9.8. You got 20.4?
Yes.
Okay, so mass equals 20.4. So what unit are we going to put on a mass? kg. Questions? No, because it's already in kg. Okay, the reason we had to divide by the 1,000 yesterday is the scales don't put things in kilograms. They're found in grams, so you have to change it to kilograms. All right, well, I handed out the last 2 lab papers that we did. You guys find your homework. Somebody left a yellow card in here yesterday. Is anybody missing their yellow card? It is not folded, and it does not have a name on it. What? You gotta put units on stuff. That is not a new rule. What? Oh, it's yours?
I did too. I got 82.
What you got? Ooh.
81. I got 18 actually.
You like 8?
Oh,
I got 28.
Yeah, I was a Rachel.
You gotta put the units on every answer, all the time. There are no exceptions to that rule except for pH, which doesn't have units there. Okay. Bringing up to school, we can scrap. Remember, I got you about probably 150 pounds. You told me the small mass is gonna go further, or something like that. It'd been fine.
We were talking about.
All right, if we look at the first one I handed back, which is the one from yesterday. The biggest mistake that was made in the table is simply that you didn't label units. I think I corrected everybody's calculations. Almost nobody messed up the calculations because I think I got everybody who was using grams and flipped it so that nobody messed up and was using grams to calculate. I can't fix units at this point, people. We're 4 weeks in. You have to put a unit on the number, okay? You have to write grams on the grams end. Kilograms. I missed one. I took -1. So, I told you to find the acceleration unit where if you didn't know it. On the yellow card. And then force is always a what? A newton. On the back side, if you put something in the data table, you got your points. On question 1, it asks you what happened when you dropped the block of wood in the crumpled paper. If you wrote down an intelligent answer, you got your points. In question 2, the crumpled paper and the uncrumpled paper, which one landed first? If you didn't say the crumpled paper, you got it marked wrong. The uncrumpled paper could not have landed first. Number 3, what could have affected their falling rate? You needed to tell me that air resistance slowed it down. Question 4, as long as your answer made sense and you explained it correctly, your points, okay? Some of you didn't explain it. Some of your answers didn't make sense. A couple of you, I couldn't read your answers. You told me that, yes, Galileo's theory was validated. Some of you said that the crumpled paper and the styrofoam fell at the same rate. Some of you said the wood block and the crumpled paper fell at the same rate. Some of you said no, it wasn't validated, that it didn't fall at the same rate because of air resistance. I took all of that. The answer I didn't take is it didn't fall at the same rate because one was heavier than the other. If you told me one was heavier than the other, I marked it wrong, -5. Okay? Does mass affect falling rate? No. And every time you tell me that one is heavier than the other tomorrow on the test of the free response, it's minus whatever the point value is. It's wrong. Question 5, same thing. I didn't care if you told me yes, the mouse fell first, or no, they fell at the same rate. Again, you had to explain it right. They fall at the same rate, Miss Wall, because gravity is 9.8. They fall at the same rate. Or you could have said, no, the mouse has less air resistance. Miss Wall, it's going to fall faster. I didn't care which one you used, as long as you didn't tell me that elephant's fat and heavy, it's going to fall faster than that mouse. As soon as you told me that mouse is lighter or that elephant is heavier, he's falling faster, then you lost your points. Okay? Yes. Now, on the second lab, the one that said inertia, you had to tell me something in the hypothesis about a mass and a distance. You could have said the lighter mass is going to go less distance, the lighter mass is going to go more distance, the heavier mass is going to go further, the heavier mass is going to go less distance. Something that had to do with the lab we were doing. Now, it is an educated guess, yes. But the hypothesis has to have something to do with the lab. You can't just say something to get credits. The distance traveled had to have centimeters on it. Now, number one, if you have a big circle with an arrow drew to the bottom, this was what lab? It was the inertia lab. Which of Newton's laws is inertia? The first. Always look back at the title if you're stuck on that question. On the questions on the back. Number 2, why do you think one box moved further than the other? As long as you told me something about one was heavier or more mass than the other, you got your point. 3A, you should have told me the one that moved farthest was lighter, less mass. B, the one that moved shorter was more mass. 4, very few people got credit. You need to write this down or you need to know it. How are mass and inertia related? The answer is more mass equals more inertia. So I would have more inertia than most of you in the room. Okay? Maybe not you. Maybe not Chris. All right? But short of that, I'm going to have more inertia than the vast majority of you because I have more mass. It will be harder to move me than most of you because I have more mass, I have more inertia. I would also, if we go back to the last unit, I would have more momentum because I have more of those two things. Question 5. The vast majority of you got 5. With what changed because you changed the mass? The distance. Now, 7 had multiple answers. Yes, sir.
I put the box because when you put the weights in the box, depending on the weight, it goes farther.
No, the box is actually one of the controls because the box did not change. The size of the box didn't change. So for the control, you could put the box. You could have put, what else did y'all put? The broom, the measuring stick, the 8 centimeters. Any of those could have been the control. You didn't change any of those things. So number 8, even though I have it numbered twice, why was it important that you use the same force each time you struck the broom? The word that I was looking for there is it's the control. You cannot change but one variable in the experiment, and you've already changed the weight. You cannot change 2 variables. Questions?
No.
All right. You got your homework from last night? How'd we do?
Good. Horrible.
Horrible? So you had trouble with it?
Yes.
Okay, pull it out.
What? I thought you said it was great.
I never said it was a grade.
Oh my God.
I said I might check it. I didn't say I was checking it, Deshaun. Stop playing what?
You had me doing my homework every night.
That's the point, Deshaun.
Don't do it, you're gonna do it.
That's the idea. So that when I do check it, you have it. Tonight's homework will be a grade. I'm telling you now, it's a test review sheet. I always check test review sheets.
No,
Ask-
you always
Ain't nobody gonna do it.
I'm telling you, ask anyone who's had my class before. I always check test review sheets. We start them in class. Some of you may finish it. Chris, you finished it last time and turned it in. But I always grade test review sheets. We will have a chance to start it in class today. I don't know if you'll finish it or not. We have 2 things to do, and I've got a Kahoot and a Plickr that I don't even have up there, so we'll see how much time we have. All right, so number 1 should be 9.8. How many people can't do number 1? Are we okay with number 1? Yes or no? Okay, number 2. Let me get Haley one. Who wasn't here besides Haley? Anybody?
Me.
Who's me? Nathan. And we're only doing the front side.
Would it be 646.8?
It would. 646.8 newtons.
Hey, let's go.
All right, 646.8 newtons. Anybody need me to do number 2?
Why is it
All right.
new? Why is it new?
Because it's a force. All right, you're calculating F equals mg. Okay, so F is your weight, mass is 66, and then gravity's 9.8. So when you get the 646.8, because you're solving for F, it's a Newton.
Anytime you see weight.
Yes, weight will be a force. Okay? Number 3 was what? 50 what unit?
G.
I can live with that, but it should be kilograms. Okay? Because it's a mass. Everybody okay with that one?
Right.
All right. Usually about 4 is where we have trouble. All right. An elevator has a mass of 1,000. What is the force if it's just sitting there, if it's stationary?
No.
All right, you're going to use the 9.8. So the elevator is hanging there. Okay? So they told you its mass is 1,000. So what's pulling on the elevator if it's just hanging there? What's pulling on the elevator, though, for acceleration? The 9.8. Gravity's pulling on it.
I got 9,800.
That's the answer. 9,800. The easiest thing I can tell you is if you're looking for force, okay? This is the easiest rule of thumb I can give you. Is if you're looking for force and they have not told you anything about acceleration, your acceleration is probably 9.8. Okay? So the question says, what is the force? Force is F. They've given you nothing about acceleration. It's probably 9.8. Now, when you read B, you're using the same elevator, except that they're telling you your force has 1,000, and you're accelerating at what rate, Nishan?
3 meters.
So you're going to use 3 instead of the 9.8. So you've got 3,000 in instead of the 9.8 being plugged in, and get 9,800, you get 3,000. All right, so same thing in C. Your elevator is still 1,000, but this time, instead of going up, we're going what? Down. At what rate? What's it saying there? It still says 3. So you're getting 3,000 newtons. Questions? Now, the next one, number 5, is like the opening question. Everybody caught up? All right, so if we look at the next one, it's like the opening question. So in number 5, what is the 1,500 kg?
Mass.
That's mass. What is 15 meters per second? That's velocity. Good.
And 5 is time.
5 seconds is time. Very good, Maria. So again, just like what we did in the opening, they're asking you to find what in the first question. All right, so how many formulas do we have that have acceleration? You have 2. So what are they?
15 and 5.
F equals ma. All right, so those are our 2 formulas, right? So if you want acceleration, what do you have enough information to use? Do we have enough to use our FMOD?
No.
Do we have force and mass to find A? No. We have enough for this one this time. So A, we don't know because that's what we want. What's our velocity?
15.
And what's our time?
5.
So 15 over 5 is 3. And that's meters over seconds. So that's A. All right, so that was A. What does B want? It wants force. Okay, so if B wants force, all right, what formula are we going to use to find a force? All right, FMA. So F equals, what's our mass? 1,500
I did.
times what's our acceleration? Times what?
3.
So 1,500 times 3 is what, 4,500?
Yeah.
Questions about how we did that? Can you do that tomorrow on the test? Maybe. You will be able to use the yellow paper. I told you, I'm not going to take it away from you unless you take notes all over it. I won't let you use it then.
Obviously, it's not a smart idea.
You don't think I'm going to walk around and see notes written all over it?
No.
Okay. Yeah, because you're a genius that way. Okay.
You know, you just told her what you were gonna do.
That's why I said that. All right, number 6. What do we know? What is 7,000? What units on it?
KG.
All right, so 7,000 kg is a what?
Mass.
It's a mass. All right, so the next number we have is 2 seconds. What's a 2 seconds? Okay. And then we have
F is 350.
350,000 newtons is a what? Okay.
The A equal,
All right, we're looking for A again. So again, what 2 formulas do we have? F ma, like the way my kids have renamed F equals NA, F ma. 26 years and I've never had F ma.
You better watch your money. I heard you. I'm old, but I ain't deaf. I didn't get this old by being stupid.
You know what I tell them about Phillips? We're just that much closer to retirement, being able to sit at home in our pajamas. Well, they have all these years to work.
Yo, why would you even say that? Like,
You know, you're gonna have to go to work and work to support us in our old age. And we're gonna sit at home in our pajamas.
All y'all's money.
All I'm hoping is that y'all are, you know,
yeah.
productive citizens to contribute to Social Security.
But you're not gonna be able to use it. You're gonna be able
Y'all taking care of it. You ain't got enough. I got no
I won't be able to retire.
I can't get one. I got 4 more right now. Oh, you got 3 more. Oh, you didn't consider.
I gotta help pay for it.
Oh.
So when I retire, I just have to get another job, to put them through college. So it'll be a few years before I can sit on the couch. Ms. Bowers might be able to retire, because she started younger than I did, so. Her kids might be out of college when she can, you know, retire from teaching. She might be able to sit home on the couch.
Oh, God.
So Ian will only be a junior in high school when I can retire, so.
Yeah.
And that's one of the niggas. This is let his dog move.
Well, Elon will be.
Yeah, see, she'll be out of school. So she could, you know, she'll be paying off some college debt or maybe, you know, help her with her master's degree or something. Alex, why are you here? Good, you said, hey, get out. Alright, so these are our 2 formulas. It's good to see you. I'll be gone.
Hey, DeAndre.
So if those are our 2 formulas,
DeAndre.
which one do we have enough information to use?
The
Alright, back to what we were doing. Which one do we have enough information to use? Alright, look at this one. For those people who said the A equals V over T, do we have V and do we have T to find A? Do we have the V? That's why we can't use this one. We don't have the V. We have the T, but we don't have the V. Keely, what you need? In a minute. Now, if we have F equals MA, F is the 350,000, the M is the 7,000, and then we can solve for A. All right, so how do we solve for A? You divide by 7,000. Kilo just means next time you need to go,
That's
you owe lunch pensions, because you're all out of bathroom habits. Take the best.
50,000.
50.
All right, it's what? 50? All right, so A equals 50 meters per second per second.
Feet per second, per second, per second, per second.
All right, so the last question is finding
Velocity.
velocity. All right, so which formula has velocity in it?
ABT.
Yep, A equals V over T.
Yeah.
So what's my A?
50.
Okay, my V,
50.
I don't know V, and my T is what?
Yes.
So what do I do?
You got 2.
There you go, because remember, this means divide, so what's the opposite of
100.
divide?
Multiply.
So 100, and then meters over
Seconds.
seconds. Questions? All right, the last question on the front said to find the weight. All right, a person weighs 540 newtons. A, find the person's mass. So what was our formula that had weight in it? F equals mg. So weight is, yep, so what was it? 540. Mass we don't know. And what's G? So how do I find it?
540, no, 540 divided by 940.
Yep,
55.10.
55.1 or 0.10. And what unit do we put on the mass? kg. Does that help with where you were stuck on the homework? Okay. Now, there's one thing from yesterday I forgot to talk about that we need to talk about terminal velocity. And then we're going to do a sorting activity with Newton's laws to practice, because there's a small section on the test tomorrow that says, is this Newton's first, is this Newton's second, or is this Newton's third law?
Just move the fourth law.
Yeah, there's no fourth law, so if you pick that one, you're getting the wrong answer. All right, and then we're just going to review, and then we'll work on the worksheets. So, if you will, find your notes.
Miss,
Look,
when I come after school to get the section,
I think I'm getting versus no.
let me see if I can make a copy of somebody's, because I deleted them. So I can give you the notes, but there's nothing written on them. So, who has good notes for yesterday?
me.
Rachel, you take neat notes? Maria, do y'all take neat notes? Yeah, she can read yours. I'll make a copy of those a little bit while y'all are working on the review sheet. Yeah, but I'm not sure your handwriting's really neat to show them. You gotta be able to read them too. It's like giving her a copy of what I write down. All right. All right, we need to do one slide. That's all we got that I forgot to do yesterday. We need to talk about what terminal velocity is, because I know it's on the test.
I mean, done.
All right, terminal velocity. You y'all ever jumped out of a plane?
No, I want to, but no.
You want to? Okay. If you ever jump out of a plane, skydive, go in the military, and want to do this, you will get experience with terminal velocity. This wall is terrified of heights. This is never going to happen to me. I'm never going to experience terminal velocity. You could. I would have a heart attack before I ever passed out. I would die.
I want to do it.
I almost stroked out going up to the top of the Empire State Building in the elevator, so I'm never gonna choose to jump out of an airplane.
I remember when I was younger, I used to be scared to go up the escalator.
I can deal with the escalator, but I can't manage even hotels with high floors. I have to be on the low floors.
So you get lightheaded on the second floor.
Seventh, yeah, I'm not going up as high as the seventh floor.
I want to.
I'm with you on that, Jameer.
What you mean?
What?
Especially if the seat was.
I told you, I'm afraid of heights.
I'd be where the crowd is at.
No, when my kids were small and they want to get close to the guardrails, or like on the patios on hotels, they go to stand at the edge. I'm like, get away from that. Stay back. I couldn't deal. I can't stand on the ground and look up at the Ferris wheel without wanting to throw up on the ground.
I was on the Ferris wheel. That
I'm not riding the Ferris wheel either.
I was like, what?
All right, so terminal velocity. is the highest velocity. Now listen. Is the highest velocity reached by a falling object. Now, not only is it the highest velocity reached by a falling object, we need to understand how it works. So, yesterday, when you guys were dropping things, the only thing you saw reach terminal velocity was the sheet of paper that was uncrumpled, the one that was flat that you dropped, okay? Because when you dropped it, what happened to it? It floats, okay? So, I'm going to draw, well, I could probably draw a leaf.
Oh, I got a question. It's like belly, but link with this. Say like a comet or
A what?
A comet or something like a
Mhm.
star or something.
Mhm.
You see it, and I know where it hits you in the head.
You're probably going to drop dead.
For real?
Yeah.
I thought when the comet comes to the Earth, it's actually going to be about that small.
Well, I'm thinking we're in outer space when it hits us because it's probably going to be destroyed coming through our atmosphere.
Yeah.
Yeah, I don't think it'll actually get through our atmosphere to hit us in the head. So I was thinking we were in outer space when we got hit.
Can I drink some water?
Yes. So, yeah.
It was an old person. I call him old head. He was like, we call old people old head.
Okay. Anyhow.
So he was like, it's gonna be an asteroid that hit Earth 20-something.
Oh, yeah, the 23rd, right?
No.
Anyhow, it's going to be an asteroid hit the Earth.
Wait.
Can they 20-something like that?
Yeah.
And then he was like, so it's gonna blow up the whole United States.
There have been lots of people who've projected that the Earth is going to be destroyed. Yeah, by various things. Whether any of that's going to happen is conjecture, so it's hard to say based on.
Ain't like the asteroid belt like right through it though.
It could. I mean, anything in outer space could hit the Earth. The question is whether it's big enough to do any damage. A lot of things that hit our atmosphere, bounce off. Some things will come into the atmosphere, but also burn up on their way into the atmosphere. So it's hard to say.
I think it's in Texas. I think.
Yeah.
Big old hole.
Yes. Some things do get through the atmosphere and then crash into things, yes. But that's well out of what I know. The last time I had Earth Science, I was in 7th grade, and I'm going to turn 48 next month. So it's been a while for me. Yes, Abigail.
Like you know how people say sometimes they think the Earth is flat and then sometimes they think the Earth is
Oh, my God.
The Earth is round. The Earth is round. It's not flat. we know it's round. We've given up it's flat long ago. It just
The gravity.
Whenever you go up in the space
Yeah.
and you see a big ball, that's Earth.
yes.
But how is it round?
It's actually more elliptical than completely round, but it's not flat.
It's not no flat ball.
Because if you see a
It
globe,
Yeah.
here it's like United States and then over here is Japan.
Yeah.
How is it going to be up here?
It just is. It just is.
You don't think like-
You ask the questions like, why is why? Why?
I'm sure there's a very detailed science explanation as to why. I just can't give it to you. It just is. Why the Earth is round at the moment, I can't give that to you. Now, hold on. What?
Why?
It just is. Now, the leaf is pulled to the ground because of what? All right.
It was the ground because the one died.
All right. We all know that gravity pulls the leaf to the ground, right?
Yep.
Now, when you think about the paper from yesterday, it floats down. It doesn't fall in a straight line, right?
Right.
So what pushed up on the paper? What caused it to float? There you go.
What you say?
I said, there you go. That's exactly right.
Oh,
All right. Yeah, that was right. Air resistance pushes up. DeAndre, stop.
Oh, no, he's talking about something else.
Okay? So gravity pulls the leaf or the paper down. Air resistance pushes the leaf or the paper up. We could even have used a feather. I just can't draw that well. The leaf is bad enough. Now, when gravity and air resistance are equal, the leaf stops accelerating. It falls at constant. Exactly, Carlos. It falls at constant speed. The thing people miss when I say it stops accelerating, they think it stops what? Moving. Okay? It doesn't stop moving. It stops accelerating. It's not going any faster. It has reached constant speed. You fall at a steady rate at that point. You don't go any faster. Okay? So if you jump out of an airplane, you're going to accelerate and accelerate until you reach terminal velocity. Once you reach terminal velocity, you don't stop moving until you hit the ground. Okay? And then it's too late. But once you reach terminal velocity, you're at your maximum speed. You can't fall any faster. You just fall at that maximum speed. You are at constant speed at that point. It's like in a race car. Okay? You're accelerating and you're accelerating. You've maxed out the speed on the car. Can you make the car go any faster? No. Okay? You've reached the maximum speed of the car. Can't get it to go any faster. That speed as long as you want to. Okay? That's terminal velocity. So you fall and fall and fall and fall, accelerating, accelerating, and accelerating. You hit terminal velocity, and then the rest of your fall, you're still going fast. You're just doing it at constant speed. Okay? Now at some point you have to do what if you've jumped out of an airplane? I hope you're going to pull a what? Pull the parachute. If not, you're going to hit a sudden stop at the end. Now, yes, you could. It's like hitting the ground. It's like hitting cement.
Having on GPA.
Huh?
By plane land on the water, you got it.
Yep. Now, let's say tomorrow on the test, I've got 4 parachutes. You jump out of the plane holding hands. And I ask you, when those 4 parachuters stop accelerating, what is the wrong answer people are going to write down? When they what? Some people will tell me when they pull their parachute. When they what? When they hit the ground is the most common answer I get when asked when they stop accelerating. What is the right answer for when those 4 parachutes? When they reach terminal velocity is one answer I will take. I will not take that answer.
When they pull their parachute.
Well, I will not take that answer. It's what DeAndre just said. You can tell me when they reach terminal velocity is fine.
I don't know what else.
What
Gravity pulls.
when gravity
Oh.
equals
When they're
when gravity equals
That's a learn.
air resistance. I will take that also.
When they are moving at the same, like even though.
Well, you said terminal velocity, but you would need to tell me when their gravity is equal to their air resistance that's pushing them up. I would take either answer. Okay, but you cannot tell me that they stop accelerating when they hit the ground, or my personal favorite is when they're holding hands. All right, you can't tell me that either. That's not true. Okay. Questions?
No.
All right. How many people do we have here today? We haven't even run out. We got 20. All right. We're going to do something like we did the other day. Let me find the right envelopes this time. see how many I have. All right, I got plenty of envelopes. Now, we're gonna find a partner. We're gonna do 10 groups of 2. All right, when we share answers, I'm gonna use the projector because it's much easier to go over the answers that way. I'm not gonna give you very long. Some of you are gonna struggle with this, some of you are not. Tomorrow on the test, there is a section where you have to figure out examples of Newton's laws, whether they're first, second, or third. I'm gonna give you 10 minutes to look at the examples and put them in the right category. If you waste my time, you're getting less than the 10 minutes. Spread yourself out around the room. Take the first, second, and third. If you're missing one of the 1s, 2s, or 3s, it means somebody's lost them. And just sort of set them off to the side. No, it's first, second, and third. And see if you can figure out which examples are which. Okay? Find a partner this time before you come get envelopes. So people don't go, this fall, there's not enough envelopes, and then people bring their envelopes back to you. Okay? They'll be sitting right here once you've got your partner. Okay? Get started. Quickly. Put your phone away and keep it away.
I know.
How can I not have an even number of people? Who's working by themselves or with an odd number? Who? Chris. Don't work with Chris over there. He doesn't have a partner.
All I know this is.
Damn,
All right, what's this? That's second. So every action.
What's this stand for? Isn't that an equation? Is
For
it?
every action, there's an equal amount.
Isn't it the second one? F mark? 12 pounds of faster down.
Devin, Nishan, come on. Talk about Newton's laws and get them sorted. Yeah, I can tell that from here.
You know you son.
Good to see Abigail. Good to see you.
We're trying to eat him off the girl.
Where, what?
Why look at you like that?
Hey, put your mess up.
Well, I got about high. Nothing, what is that? Let's go. Come on.
Which I do for the someone person as well.
Hey, Maria, can I borrow your notebook real
I
quick?
can't believe I let Nas down.
Yeah,
It's just one page.
because, yeah.
I thought it was one day. Take pictures. Take pictures where.
Let me turn on the projector. We can do this.
Oh,
right, is everybody with their group people? So you get to see. Because we're just gonna put these where they go, and you need to check to see if you put it in the right spots.
Oh my God.
Let's
We're
not.
lamp.
Like,
Cameras on.
All right, was it not? On there.
And what?
I can see it here on the board. Why can't I see it up there?
Huh?
305.
Okay. Oh, nope. Picked up through this today. Terminated. Why? I didn't terminate anything. Apparently my idea is not gonna work. I can see it on the computer, but it will not show up on the smart board. Given it won't work, we'll just have to do it the old-fashioned way. So, yeah, so my idea's not gonna work. It would have worked had they not switched out the laptop to try to fix the problem the old laptop is having up here. So, where'd you put an object at rest? Will remain at rest. An object at rest stays at rest. In Newton's first law, that's where it should go. All right, find a ball rolling on the floor, which stops because friction is applied. The ball rolling on the floor stops because friction is applied. That should be the first law. Okay? It's in motion, it stays in motion. The friction causes it to stop. A 12-pound bowling ball goes faster down the lane than a 15-pound bowling ball. That's the second. Force equals mass times acceleration. The two bowling balls have a mass. One goes faster than the other. That's the second law. All right? If I slap you with a force, I can hit you. Your mass of my hand times the acceleration towards your face. That's the second. It's talking about mass and acceleration. Someone crashes their bike into a rock and is thrown to the ground.
First.
That's first.
Man.
Carlos, I need y'all four to stop just standing there talking. Okay? I need the two of you who were in the group to turn around and look at your answers. And I need the other two to check y'all's answers.
Oh, we
Okay.
are.
Okay. Then do it without talking. So, why is it the first law? You're riding the bike, right? You hit the rock, and where should you stay? On the bike, but because the bike hits the rock, what happens? You continue forward on the bike, so you are thrown over the rock.
I flip.
Never done that.
I have.
If you let air out of a balloon, and the air pushes the balloon, and it goes all around the room. That's the third law. Very good.
What's that again?
If your air is let out of a balloon quickly and the air pushes the balloon up and around, that's the third law. More force equals more acceleration. More force equals more acceleration. That's the second. Force equals mass. Force equals mass times acceleration. Okay? It takes less force to push a bike than a motorcycle. That's the second one also. All right? A fireman turns on his hose and is knocked backwards. That's the third. Because the water goes out and the fireman goes where? He goes backwards. So that's for every action, there's an equal and opposite reaction. The water goes one way, the fireman goes backwards. All right, have any of you ever done pressure washing before?
Me.
If the water goes forward and you get pushed backward, same concept. All right. If you hold the box against the wall so that it's in equilibrium, the same force you're pushing on the box to hold it there, the wall is pushing back towards you with the same amount of force. Third law. Equal and opposite.
Like, you pure definition, you call it,
Yeah, that's the third law. That's the third law. You got the right idea. It's just the third law, not the first. The amount of force you exert on a shopping cart and the mass of the groceries inside determines the acceleration. Second, a seat belt stops you from hitting the windshield. That's the first law. Will not move until you kick it. That's the first law. Player. Second, the door that pushes back with equal force. Third, for every action, there's an equal and opposite reaction. Third, in a plane taking off, you feel like you're being pushed back in your seat. First. Feet push down on the floor and the floor pushes up on your feet. That's the third. A boy can throw a football farther than his friend because he uses more force. Second. No. You push a large box and a small box with the same force, and the small box will go faster. Second. It's talking about force and faster. If you hit the gas in your car and you hit the back of your seat because your body wants to remain still, that's the first. That's inertia. Bowling pins. If you hit the bowling pins and it sends them flying, that's the first. They were at rest. A person doing push-ups on the floor. That's the third law. An object in motion stays in motion. First. You have to push a heavy ball harder to get it to move as fast as a small one. Second. Very good. All right, take your things and put them back in the envelope. Put it back on my desk. I thought we might do some flickers quick and then we're going to stay guys.
You said we doing Peru?
We're going to do the flickers. We're not going to do all the questions I have in it, just so come on, get your envelopes up here, get your blicker card.
I think I'm three.
Probably are.
Just walking.
Get your envelope up here, get your blicker card.
What are you talking about? What's number? I forgot what number it was.
I don't remember what card I am, but I think I'm 17, though, if I'm not mistaken.
What number was I again? 14 or 8?
Sign it in now.
Signing in.
There you go. If you don't know your number.
Who got 17?
I got that one.
There you go. There's your number. I'll grab my iPad.
That's one over. It's not the first
No, it wasn't me, bro. Keep trying to play with me, bro. I will be at your house today. Don't play with me, bro. I will find out where you live. Who got your record?
All right, does everybody have the card? All right, who doesn't have their cards? Anybody?
Devin said he got his. I need
You keep 511.
You know how you
No, let's do that right. Let's do that right. Come on, youngest.
All right,
Oh, man.
I'm not leaving that up.
Anybody know the numbers?
Right.
What you mean, no?
All right, so read the question. We're only going to do probably about 5, and then I'm going to give you the review sheet so those of you who want to get started on it, so you have less homework, because I already told you, I will be grading this
Can you
tomorrow.
be quiet so I can read it?
That's nice. I would have you want to class.
Man, nobody get this wrong. And the answer is A, bro.
the answer is D.
Get out. Both of y'all.
You don't want to be here. Leave.
Answer is
Oh, wait.
Answer is D, bro.
Wait.
That's C.
Hey, like all these answers look off, right?
Turn a little bit, Jonathan.
You like
Jonathan,
C,
turn
right?
towards me.
Really, you want to go A and C,
There you go.
so it's going to be a D.
It's wrong.
There you go, Maria.
Same, like gravity.
Jameer. There you go.
Oh, you got one?
Yep, all right. Everybody got it but somebody who was absent. So, when we look at that, all objects fall at what rate? 9.8, and is due to gravity. All right, somebody who's absent.
Ah.
All right, what's the weight of a box? Somebody wasn't here, so that doesn't matter. What's the weight of a box?
It's D. Oh yeah. I know you got a lot of work. Yeah.
It's a whole lot of games, boys.
A lot of games.
Happy birthday.
Drew, I think your hand's in the way of the block. Yeah. I got it that time. All right, so we got 6 people who got it wrong. All right, so when we calculate weight equals F equals mg, right? 5 times 9.8 equals 49. Okay?
Sean got it wrong. He ain't allowed to answer that time.
Well, you know I got it wrong. I picked D.
He gonna put that for everyone.
I ain't ashamed with my pivot.
Alright, if a boxer punches their opponent, the force will be the mass of their hand times their acceleration. What law is best illustrated?
Yeah.
I hope you don't pick D, give it D's on there.
It's D.
Answer is
Oh, we don't care.
We don't. We don't care that you don't care.
You're right. I don't care that you don't care. You don't care.
Stop arguing. I can go home and listen to children fight. Or argue.
You ain't gonna not pay my bill. Bro, yo. Bro, it's really ugly. Like, he got family.
Looking like this.
Look like a kid.
You show what you got.
Little bit.
In a smaller version.
Alright, so Cynthia, I didn't get you. Alright, so we're 14-6. Alright, 14 of us said the second law, which is correct. See how it says mass and acceleration in there? Mass and acceleration is the second law. Okay? The third law is equal and opposite, and the first law is inertia.
Y'all might as well just go out to the store and buy y'all own Texas Instruments and y'all just keep dropping the calculator.
Yeah, he stopped the whole class. Man. Can you buy me one?
Yeet.
Alright,
$100.
one more after this
Already
one.
got one.
Answer this one, and then I'm going to give you one more. Heavy dresser that will not move. What type of friction do I have?
Ooh. That's no
Bro, it's sliding, bro. You gotta slide.
This is what we call formative assessment.
It's not.
We don't grade formative assessment. Tomorrow is summative assessment.
It said it will.
Right.
This will be on the test.
Look.
You will see stuff different.
Okay, we see them on go.
No. Look at that. You put roll. They don't got no wheel. I know that.
Come on, we only got 15 minutes. Let's go.
You're right.
Trick somebody.
Keep
I'm gonna
going.
take my time to answer this
Hey, bro, it's
Y'all can't hold it at weird angles and expect it to stay.
This is how we do it.
Alright, so we got 18 people with the right answer, 2 with the wrong. If it doesn't move,
It is static.
it is static.
Show yourself.
Alright, one last question. Let's go with this one. Alright, one math question to end all. Last one.
It's always move the decimal. Why? Why?
Do a math one to finish.
Should be out there.
Hold on. Let me get a few more cards to pop up.
Go ahead, so that-
Oh, I know what it is, bro.
What's your answer?
Now, push your chicken in the mouth.